Hello everyone, thanks for coming, thanks for the interest. So first one out, and I'm actually talking about a topic which I know is maybe not the most popular in the wreck fishing community. It's the contaminant exposure by eating own catches, by eating seafood. And I brought you some principles and ways to assess if there is a risk or not of consuming our catches, and some case studies from Norway. So let's start. What is actually the issue? Or what do I think is the issue? We know from catch data, we have many wreck fishes that catch something, like the boa up there, and we know that all seafood species, all fish species actually contain some contaminants. That's just how it is. That's how it is in this world. However, we also have some fishermen who actually catch a lot, potentially eat a lot of fish, and we also have fish that actually contain quite some contaminants. It might be because they are large predatory species, or because they are from, for example, contaminated areas. And then we get a high exposure, potentially. And how can we assess if wreck fishes are at risk, if there's a risk of eating their own fish? And from experience, what I see is often fish are measured for the contaminant value, and then people refer to the maximum levels in seafood, which often are given in legislation. EU context, we have one directive that tells us if a fish contains this and this much of a certain contaminant, it's not allowed to be traded on the seafood market. However, this is not really specific for the wreck fishes, because they might actually eat much more than what these advices are based on, which is the general population. Then there's another way of examining recreational fishes and their risk, and this is by using biomarkers. This is actually a quite exact method. There you can take samples of humans. You can take, for example, hair or fingernails if you want to measure mercury or organic pollutants by taking blood samples, and then you measure them. The drawback here is that it is very expensive, often, the measurements, and it is hard to get the samples from experience. And therefore, for the moment, we are working with another approach. We are using the existing health-based guidance values given by European context. Again, EFSA, US have EPA, FDA with this guidance values. In the European context, they are often based on weekly intake, so we call them tolerable weekly intakes. That means how much of a certain contaminant you can be exposed to throughout your whole life without expecting any negative health outcomes. And these are directly relevant for wreck fishes. How? Here I brought you a figure of the tolerable weekly intake for mercury. And what we see, for example, the higher the mercury concentration, the less fish per week you can eat. Makes sense. If we now have a measurement in a certain fish, seafood species, whatever, here I brought you the average in our Norwegian Atlantic bluefin tuna of the lean muscle. You have 0.83. You can go in here, go to the curve, go down, and you will find, okay, we can consume 100 gram per week if you assume you are only eating this species. So it gives you kind of a clue how bad is it or how good is it to eat that fish. So if we have the TWI occurrence data, this is what I will call the actual data of the contaminant in a certain seafood species, you can say how much fish is safe to eat. However, if you want to integrate it on a little bit larger basis and want to integrate more fish and maybe have a more integrative approach, we can use occurrence data, how much do we have in the fish, plus the seafood consumption data. And this data is sometimes available in some countries. We have regular assessments of the seafood consumption, or you have to again, if we combine this data, we know the exposure, and to see if there's a risk, we can compare the exposure with these TWIs. And then some examples from Norway, what we have been doing so far. So this is a single species approach here. We have the brown crab in Norway. It is quite an important recreational species. It's quite easy to catch, and it is consumed. And we have an interesting story because we have quite high levels in the northern Norway and lower levels in the south of cadmium, which is the main, one of the main issues in the species. And again, as explained, if we measure how much cadmium we have in this crab, and we have the TWI, we can calculate. In this case, we could eat 40 grams of whole-cooked brown crab from the south, 12 from crabs from the north, taking into account the contribution from other food, which is quite big for cadmium. It's a little bit different than mercury. But if you want to look what is really happening in the population, here we had some existing data for the consumption. And if we have this, we can compare the actual exposure just by multiplying the intake by the occurrence, and we see how does it look in comparison to the tolerable weekly intake. And for example, here we would see the average consumption consuming crabs from the north are actually exceeding the tolerable weekly intake by 300%, or exceeding by 200. And if you would eat crabs from the south, you are fine. Then we had coastal consumption. So this is what we got from the data what people actually are eating. They eat more, and they even by eating the whole crab from the south, they would be around the tolerable weekly intake. On the other hand, we know that many people only eat the claws, not the inner meat, so they were fine in this population. And then there was also a high coastal consumption, which was even higher, which might be true for recreational fishers, so that was actually even two times higher than the coastal consumption. So this is the guys I was talking about in the beginning, the one on the right side, catching a lot, having some high concentrations. Then we had a also quite targeted approach. Here we had a good opportunity to look into the nephrops fishers in Norway. It's not so many right now, but they're getting more and more, fishing for Norway lobster. And there we looked into mercury. So this is this guys up there, and first we measured the concentrations, and then we did a small food frequency questionnaire on these people to see how much they are actually eating, both of their own catch of the nephrops, but also for other seafood for dinner. And then what we often do is we have different scenarios in these assessments, and here it's a little bit difficult to see, but anyways, I will guide you through it. So we have, if we assume or look at the nephrops catches and the exposure, actually everything was below the TWI, which is 110. But if we looked into the exposure from seafood for dinner, again, high consumption and the high concentration potentially, or in this population, actually led to an exceedance of the TWI. However, this was very targeted. As I said, this was single species, which we were looking into, where we knew there might be some issues. But now we decided to go a little bit broader, and we did an assessment for the recreational fishers, including many species. And for this, the first task was to get the consumption data. And there we had a food frequency questionnaire, so people had to answer for many different species, actually all or most of the species we thought could be relevant, how often they eat it, what portions, both for dinner and otherwise, and here we used store-bought versus self-caught. So what is their own catch that they are consuming? And the participants were people planning to go fishing the next year. So we consider them recreational fishers. But you all know, working with surveys, it's not that easy always, but this was our approach in that case. And if we look into the consumption itself of seafood, it's quite interesting. So here we have the recommendation. In Norway, we have a recommendation that you should eat 300 to 450 grams a week. And many of the fishers actually are at the recommendation or over. And you have, again, some extreme individuals that eat a lot of seafood. And comparing this to the general population in Norway, this is much higher. This is unusual. What is consumed? So there are some species that dominate. We have the shrimp, which is Norwegian deep water prawns. They are quite popular. Then we have salmon, and here it's indicated self-caught or purchased. So you see salmon, this is a farmed fish. So there is definitely some wreck fishers going for salmon, but most is of course farmed salmon that is consumed. Then we have safe and caught. This is quite popular recreational species, and there we see also that half of it, or around half of it, actually comes from the self-caught or from their own catches. And then, again, to remind you, we need both consumption data and occurrence data. Occurrence data, in Norway, we are in a rather good situation because we have large studies that have been ongoing for quite some time, monitoring different types of contaminants in different types of seafoods. So we have even our own database from the institute, which is open source for the ones who are interested in values from the North Atlantic waters. And we use this contaminant data, mercury, which I will show you, and different POPs, which we are working on. And we have done two different scenarios. One is store-bought. There we just took the mean, the median of fish caught in non-contaminated areas, which we think is the most representative for fish which is traded on the seafood market. And self-caught, we assumed that the values are higher because we know that recreational fishers often are fishing closer to the shore and often in more contaminated areas because they're often not aware of the contamination. And what we see is that a small number, luckily, only exceeded the TWI. It was only 2.22%. So again, this was the extreme consumers that went over here for mercury. But we know also if we start to look into the organic pollutants, it will look a little bit worse. But then, it's not only about the contaminants. It's the whole package we are eating. We are not only eating mercury or getting exposed to mercury from seafood. So therefore, we also looked here into the nutrients. We selected some of them, went into the existing open source occurrence data, and then here we found something, and this is that participants meeting the recommended daily intake, so there is something similar to the tolerable weekly intake, just what you should ingest for nutrients. We see that, especially for EPA and DHA, we had quite a good contribution for this population, not so much for the other nutrients. And just quickly, to round it up, I wanted to mention this because I think especially for middle and low income countries, this is very interesting, and this is looking into food security. And the principle is quite similar to what I've been explaining. If we have nutrient data on the nutrient content, if we have catch data from recreational fishers, and we know these recommendations, we can actually calculate the potential contribution of wreck fishing to food security, which I think in these times of preparedness is an approach that we should follow up on. And we have done one, or my colleagues have done one study on the small-scale fishery in Norway, and they showed that it was a significant contribution could come from the small-scale fisheries. Thank you so much. That's interesting. So this is what I worked on during my PhD. So we have some ideas. We don't know really yet, but it is connected to different, most probably different migrations of the crab in the north. The water is colder, so they will migrate down during the winter and most probably feed on other things. And we know that they are shedding, casting their shell less often in the north. So they are growing slower. So therefore, they have more time to accumulate at the same size. Somewhere there.
Thank you so much.
Thank you.
Thanks for